Hi everyone, what's up? Welcome back to my tutorial channel. It's Danielle here, and today I'm going to show you how to run the z-test for a population mean mu when sigma is known using the calculator TI84 CE. Similar to the z interval, there are two types of problem. One is when you are given the sample statistics, and one is when you are given a data set. And we are going to use the function z-test to deal with these two types of problem. So let's take a look at the first one. Given the sample statistics, a sample of size n is equal to 80 is drawn from a normal population whose standard deviation is 6.8. The sample mean is 40.41. Given the significant level, 0.05, one claims that the population mean is about 40.3. Is the claim true? So here we have couple information. X bar is 40.41, which is a sample mean. The sample size is 80, sigma is 6.8, alpha is a significant level, which is 0.05. The hypothesized number is 40.3, and the claim is the population is about 40.3. So the null hypothesis is mu is equal to 40.3, and the alternate one is the opposite statement, which is mu is not equal to 40.3. So this is a two-side test, right? So we have summarized the question, and now we are going to use the z-test to test the claim. So now let's take a look at the calculator. Alright, so this is my calculator. And in order to run the z-test, we hit on Start, choose Test, and choose the first option, z-test. The first type we are given statistics, so go ahead and choose that over dataset. Now mu naught is the hypothesized number, and mu naught here is 40.3. This number we found in the statement, in the claim. And then sigma is given as 6.8, and sample mean is 40.41, and then the sample size is 80. The alternate hypothesis is mu is not equal to 40.3, and 40.3 here is mu naught, you see that? So the alternate hypothesis here is mu is not equal to mu naught. And then the next one, the color, it's just the color. I don't care about color, so I skip this step, whichever. I can change to red, blue, whichever I want. And then calculate. So this is the result. We are using the z-test, and the result is the z statistics. This is the test statistics. Z is equal to 0.144686755. The p-value is 0.8849581511, and because the p-value is less than 0.05, p-value is greater than 0.05, we do not reject the null hypothesis. So we accept the null hypothesis. Alright, so that was the first type. Now for the second type, a random sample of 12 ounce milkshakes from 14 fast food restaurants had a following number of calories. Assume that the population standard deviation is 90. The population is approximately normal. One claims that the mean number of calories for all 12 ounce milkshakes sold at the fast food restaurant is at least 500. Test the claim. And we are given the data set here. So let's summarize the question. The alpha level here is 5%. You might question why we have 5% here, where it came from. So usually if the question doesn't give you the significant level, we take the scientific significant level, which is 5%. Because remember, an event is said to be unusual if the probability is less than 5%. So that is where the 5% come from. I repeat, if the question doesn't give you alpha, then alpha is 0.05, which is 5%. Sigma here is 90. Now we look at the claim to define the null and the alternate hypothesis. Here the question said at least 500. That means mu is greater or equal to 500. And the opposite is mu less than 500. So here's the thing. When you define the null and the alternate hypothesis, you have to define two opposite statements. And the statement that have equal sign is the null hypothesis. So the non-trig inequality is the null hypothesis, and the trig inequality is the alternate one. See that? And look at the alternate hypothesis. Mu is less than 500. That means we test on the left side of the number 500. So this is a left tail test. Alright, so we are going to use the z-test function on the calculator. Now let's take a look at my calculator. Alright, so this is my calculator again. For the second type, before you run the z-test, we have to enter the dataset. So hit on Start and go to Edit. Here I have already entered the dataset into L1. And once the dataset is already in list L1, I'm going to hit on Start and go to Test. Choose z-test. And for this time, I'm going to choose dataset. You see that? And then clear out the old number. Mu naught here is the hypothesized number, and on this question we are given 500. This number is found in the claim. And then sigma here is 90. List L1, frequency 1. The alternate hypothesis is mu less than 500, so you have to choose the middle option, mu less than mu naught. And hit enter. And then for color, choose whichever you want, and then hit calculate. Alright, so this is the result. The test statistic is 1.167, and the p-value is 0.88. Here p-value again is greater than 0.05, so we do not reject the null hypothesis. Remember, if p-value less than the significance level, then we reject the null hypothesis. But here p-value is greater than 0.05, so we do not reject the null hypothesis. So that is it for today. Thanks so much for watching. I hope to see you guys on the next video. Bye bye.